Hello and welcome. We're going to do the 2023 AIME II Problem number 12. I will assume that you have read the problem statement. If not, take your time right now. It's a little complicated, so I recommend you read it before viewing this video. Okay, I'll assume that you have read the problem statement now. So what we're going to do is we're going to include lots of geometry. And not only geometry, but even a little bit of algebra in this geometric problem. It is a little complicated. You will have to know things like the law of cosines, stuff like that. And I would just say that if you want to get a good understanding of this problem, you can also go check out the AIME solutions written by other people. But I would say, yeah, this is okay for most people in high school if you understand a majority of algebra. So what we're going to do here is we're going to create a diagram. So this diagram is pretty simple. It's just following all the things that the normal problem is supposed to have. If you read the problem statement, it should be pretty easy to draw out. You should know that it's going to be like this. And in addition to that, you probably can figure this out in the real test too. Okay, so now we're going to move on to the actual solution. So what we're going to do here first is we're going to review the law of cosines, as I said we would use. So the law of cosines is pretty simple. If you have a triangle that I've showed here, you can get the three equations that I've written out right there. Okay. So now after we review the law of cosines, we're just going to implement it into our problem. Okay, so we find that AB squared is equal to AM plus BM squared minus 2AB AM BM cosine of A, M, and B. This is using the triangle that was in the problem. The triangle is ABM, and we similarly find the next two equations. We manipulate these equations to get what we have, or to get what we have there. And then after that, what we're going to do is we're going to simplify it and combine some equations to get the final equation, which I've shown in the diagram. Okay, I will assume that you are done reviewing those. And now what we're going to do is we are going to do some a little more algebra, and we're going to use the power of point M. If you don't know what's power of a point, you can go figure it out. It's a like series of theorems, and if you don't know that, I recommend you go check them out because it's actually really useful for AIME and AMC problems. In general, it's pretty good. And just like check it out in general. So now we're gonna move on. So we use the PowerPoint with respect, circumcircle ABC, and we get AM plus, IM not plus, times MP is equal to BM times CM is equal to BM squared. PM is equal to the following. And we can figure out and estimate the values. Okay, so now what are we gonna do? So here's this small diagram again. It is clear that if Q is equal to P, then angle PBQ and PCQ are all zero. If Q is symmetric to P with respect to M, then angle PBQ is equal to angle PCQ. There exists a unique point Q on segment AB, AM, sorry, PM is less than AM. So then we find our answer. PQ is equal to AM minus PM, which is the following equations, and we get the answer 247. So just as a quick summary, this problem was a little hard. I mean, if you don't have that, like algebra, or not even algebra, like geometric foundation, it might be a little hard to learn it, but at the end, it'll be fine. So if you want to learn this problem with other solutions, if you can't really like understand this one, recommend go check the AIME solutions. Okay, so this was the 2023 AIME II problem number 12. Hope you have a good day and bye.